Maori, Talofa, Bula, and I suppose g'day to everyone listening. Thank you for listening. I'll be focusing on the soil management component of our project. So my name is Jeff Dean and I'm with the University of Tasmania. At the bottom, you can see the list of participants in the project, and I think we formed a pretty good team. So just running through the specific research questions that relate to soil management. So firstly, what soil constraints are limiting food production on atolls? And how can soil health be improved with the resources available in the atolls? What is there that we can use for making things like compost? And will improved soils increase the productivity of crops being grown in Kiribati and Tuvalu? What are the soil constraints and the issues on atolls? Well, firstly, we've got the chemical side. So low nutrients is the big one. And also associated with that is a low cation exchange capacity. So the ability of the soil to hold on to nutrients. It's a form of fertility, if you like. In addition, the high pH is a constraint to growth, so very high alkaline soils. This is a result of the coral. So the soil is being formed from the coral, washed up as on the right-hand side. The other restriction is in terms of using inorganic fertilizers and also the soil physical properties, so that sandy texture. So with both of those factors, any fertilizer that can wash through the soil fairly quickly ends up in the fresh water, and the freshwater lens here in the bottom of the well, and it's not a big drop from the surface down to the bottom. So there's environmental implications with what we do with our cropping as well. So when it comes to the plant growth, then often we'll see symptoms like this. So you can see a chlorosis of the leaves, a yellowing of the leaves, and in this case, the green veins. So it's probably symptomatic of iron deficiency. So chemical properties, low nutrients, physical properties such as the sandy texture and low water holding capacity do lead to reductions in plant growth. So that's what we were setting out to tackle. Coral lime nutrients, you can see on a graph here of various nutrients. Calcium Ca is the big one, again being derived from coral, and there's moderate amounts of magnesium, Mg, compared to some of the other nutrients there. So we have nitrogen, phosphorus, potassium, sulfur, iron, manganese, zinc, copper, and boron. And when you have a comparison with the soil, local soil, you can see that the profiles do match. So in terms of calcium, by far the biggest nutrient in the soil is calcium, and similarly magnesium. So the profiles of the soil, not surprisingly, tends to match that of coral. Now, if we just we take out the calcium and magnesium, and we just look at phosphorus, potassium, sulfur, iron, manganese, zinc, copper, and boron, those that are in lower amounts. Couple of interesting things. One is this phosphorus. So we've got low amounts of phosphorus in the coral and good levels or much higher levels in the sand, in the soil. And similarly for zinc. And you might wonder, well, why that is. This is not an uncommon sight. So you're seeing bird droppings on leaves. So birds are coming in. There might not be much land around. The birds might have to fly hundreds of kilometres. And then obviously the little bit of land that is there tends to get well utilised. So although it's not building up to the sense of guano deposits, there is higher levels than we would expect in phosphorus, and then lower in the other nutrients. And just to reflect on the amounts that are the critical levels. in terms of whether you'd say a soil is deficient or not. So that's these red bars here. So for phosphorus, a critical level might be, say, 35 milligrams per kilogram. And so you can see here that we've got sufficiency. And my observations or my tests to date have shown that most of the time the soils are in excess or have enough phosphorus. And that's using a few different soil tests as well. So if you go back through the literature, certainly some people have implied phosphorus deficiency, and you would expect the phosphorus to be tied up with the calcium, but the levels here suggest otherwise. And one of the tests I've done has been in alkaline soils, calcareous soils in South Australia. So a test developed for those soils to pick up the amount of phosphorus, a specific test for phosphorus, and that has shown up again moderately good levels of phosphorus, and total levels of phosphorus are really quite high as well. So I'm not ruling out phosphorus as a potential problem, but certainly it's not as deficient as been written in the literature. Potassium, well, that is deficient. So here's our level around 100 milligrams per kilogram, and the soil is down here. So a big issue with potassium, and given that potassium is needed in quite large amounts, particularly when you're growing starchy food crops or even fruit such as tomatoes, then you need relatively high levels of potassium. And then obviously sulfur isn't a problem, and that's probably from sea spray blowing in with sulfur, so depositing sulfur. Then these other nutrients, the trace elements, iron, manganese, and copper, are all tending to be on the low side, and sometimes quite low. So that's what we're dealing with, and so the question is how we fix that. Just going back to the title, so improving soil health, agricultural productivity, and food security on atolls. Can I actually break that down to improving the soil health then leads to improvements in agricultural productivity, and then we're overcoming the problem of food security. In terms of the objectives for my work, it covered both objective 1 and 2. So 1 being productivity of starchy foods, and objective 2 was more to do with the local nutritious foods, so the leafy vegetables. So in both cases, that's the soil management research that was being conducted there. And what did we actually do? Well, this is just an overview. So we'll be talking in detail on day 2, which should be Thursday, about some of the results. But as an overview, the first thing was determining the most limiting nutrients in the soil. So I've already touched on that. This was mostly through laboratory analysis that I organised in Australia, but Dr. Siwa also had the Palin test for local testing as well, and another test. So to work out what are the nutrients that are most limiting the soil, and then targeting those nutrients in whatever products, whatever resources are on the islands. So for instance, ash. So ash from coconut shells and coconut husks is surprisingly high in potassium. 8%, maybe even higher, commonly 6%. And ash from other wood that is burnt is usually only around 1 to 2%. So that's a huge bonus for using in our agriculture. There are some issues with ash, so going too high is a problem. So in the next session, we'll talk about some of those and what were the optimum rates. But given that the ash from coconut shells and coconut husks is a byproduct of copra and is already used in cooking fires, it's a resource that we definitely need to tap into. And then there are other leaves. So certain leaves are high in particular nutrients and consistently high, surprisingly consistent in the results. And Graham Lyons will be talking about that from the human nutrition side. I've come at it from the feeding the soil side. So some leaves, such as this Vigna leaves, yellow beech pea, high in iron in particular, but also good levels of potassium. So it's an ideal one, and it's also something that grows next to the coastline. It's you'd call it a weed, except that it's useful. Seaweed's another one. So levels of potassium, some seaweeds 6%, some are higher again. So, but species specific. So making a compost, knowing what the nutrient deficiencies are, targeting those nutrients in whatever is available, and then producing a compost. Of course, the other one is manure. So manure, we'll talk again later, but manure has a lot of nutrients in. So compost has obviously good levels of carbon in there, but we can also add carbon through other means. So one is biochar, charcoal, but also coconut coir, doing trials with that in Australia, and the rotting coconut logs as well. So to help with that, in particular with that soil moisture retention. So various pot trials and field trials conducted in Kiribati and pot trials, at least in Australia. And then finally, we were looking at alternative production systems to reduce soil and water limitations. So wicking beds in particular. So we had looked at those for the last few years, but in the last year, a fair bit of work, or quite a lot of work, has gone into food cubes. So that's the highlights of the research activities. And yeah, the next recording will actually be running through that in detail. So this is just being an overview, and we'll have the detail in the next session. So thanks very much for listening, and tune in again.